Okay. Hi everyone. Thanks for joining our webinar today. Enable process optimization through design of experiment. So I'm Salawati. I'm the technical support specialist at Visit System. So Visit System are independent representative Minitab for Malaysia, Singapore, and Batam, Indonesia. So a few housekeeping notes before we begin. We have a Q&A session after the presentation. So please submit any question you have and we will try to do our best to answer them. If have time, if no, we will answer afterwards by email. So we recommend viewing this webinar on your laptop or PC for the best result. So please fill out our survey before you exit the tab. This survey will help you help us to improve the quality of our upcoming webinar. So we record this webinar and upload to our website www.basic.com and our YouTube channel Minitab Malaysia and Singapore. So there's no problem if you miss anything or you want to review afterwards. So Minitab was developed in 1972. So today I think more than 50 years in market. So we have a consist of the others software. We have a Minitab Connect is well for the data transformation and the dashboard. And then we have our flagship product, Minitab Statistical Software itself. And then we have the software predictive modeler for the machine learning and the predictive analytic. So now some of the algorithm inside the SPN available in Minitab Statistical Software. So we have also, we call it the Minitab model ops. So that one is something like enhanced or extension. After you have your models, you want to do the prediction. So we have the Minitab model ops. And then we also have the Minitab workspace. It will be for visualization tools. Let's say you want to see FMEA, something like one. So we have in the Minitab workspace. And then we have the Minitab Engage. It will be some additional or extension from the Minitab workspace itself. We have the dashboard for the continuous improvement, something like one. And then we have the Education Hub. It's an online training. It consists of few models like statistical quality control, the OE, regression, and so on. And then we have a real-time SPC. So that one is for you want to see your control chart, your capability. They want to see the notification or real-time action you will get from the real-time SPC. But today we focus on our flagship product is a Minitab statistical software. But if let's say you interested with the other products, so we know, and then we can do the product demo for each of the product here. So Minitab has come out with the statistical tools. So we have for quality side, we have the MSA, measurement system analysis. We cover for both data set, whether it's a continuous, so we go for the gauge study. So if let's say your your response is the attribute, we go for the attribute agreement analysis. And then we have a control chart capability. We also have the acceptance sampling and then tolerance interval. So we have for the reliability engineering. And then also we have for today session for the design and experiment. And then we also have the something like a business analytic where you have your historical data set. You want to see the model, you want to see the prediction, something like that one. So we have a lot of algorithm inside the Minitab statistical software. And then of course, we also have consist for the process validation. Okay, so for example, you want to see the MSA, hypothesis testing, ANOVA, and so on. So all this one is incomplete. Okay, and then that one is our customer coming from the various sector, is including manufacturing staff, academician services, and so on. So all the type company also fit to use software if their purpose to use the statistical to be the data-driven company. So this software is not for the big company, can be for the SME and so on. As long as you want to see or you want to use the statistical analysis into your company. Okay, so for today's session, let's say a mini quality improvement project requires some of the experimentation on your process. So for example, the chemical engineer will wish to determine the setting for the certain process variable to optimize the critical quality characteristic of the resulting product. So for example, also a material engineer want to run a plastic injection molding process using the different grade of the raw material and determine the which produce the least variables in the breaking strength. So let's say you have this kind of the problem, okay, whether you are chemical, you are the material, you are the industrial, you are quality side engineer, something that one. So all that one. So if let's say you related with the experiment, so today we try discover how easy we use the Minitab to do the design of experiment. So we go for the design of experiment itself, and after that we try with using the assistant menu to discover for the screening design, and after that we try from the route one is we go for the part factorial design. So hopefully in 1 hour you will get some information, okay, from this webinar. So many quality improvement project requires some of the experimentation on a process. So one factor at a time, okay, is a common use by the engineer itself. Okay, there is more experiment are needed, which result in higher costing. Maybe they will longer time, and then information about the interaction itself, it will be the loss since you using the one factor at a time. Okay, so instead do the one factor at a time, we have a comprehensive or systematic module. We call it, that one is the design of experiment. It will be a powerful. Maybe you can see our in our case study. Okay, so we have a lot of a successful story about the design of experiment itself, and then it will be efficiency statistical approach for the process and the product optimization. So we try to impact to study or explore of multiple variables on the outcomes. Okay, instead you do one factor at one time. So now we try combine together and then find out which one is the best for your response. And then of course, after you know your best factor or parameter, you want to see what the level for each them. Okay, so that one is the variety situation. You will use the design of experiment is you already have something like you already identify the factor. Okay, you have a list of factor from your brainstorm, let's say from your FMEA, from your fishbone diagram. So you can collect them together. Okay, and then they will allow the multiple input factor or parameter to be manipulated to determine the effect of desired response. So design of experiment is not for the continuous data set. It will be for the attribute data set. So it's a okay to do the design of experiment. So if let's say that one, okay, so you in the DOE, they will ask this question, something that will answer this question. Some you have want to see the which factor has the biggest influence, okay, and which one has no effect into your output. Or maybe you want to see the interaction, okay, between the two or more variables. And then of course you want to see the setting can optimize it, the output. And then we always use, or we use the design of experiment to try to understand the critical input or parameter. So we want to optimize our process and the product. And then of course, we want to accelerate the development of our project. So here it will be some successful case study from the various of the organization across of the world. Okay, so the one is you can see this case study in our website www.minitab.com. Okay, so we have they use the different side of the design experiment itself. Okay, so before we go further, just this one is just highlighted. I think all of us always do the experiment using the secondary school. Okay, so we have the outcome or response is something you measure it. So whether it will be continuous or attribute, okay, and then your factor, or maybe you see the variable, or maybe you call that one is a parameter. Okay, they will wish the active change to influence the outcome. And then of course they will be have something label your setting of each your factor or each your parameter. For example, your temperature, it will be low and high. Okay, your diameter, it will be long or short, something like one. Okay, and then we have the some here experiment example. For this case, we want to boil the water, and they want to measure the time of boiling of the water. So they come out with the factor. They have a type of code, which is that they have a two level, is a classes and the metal. And then the another factor, it will be electric heat, it will be low and high. And another factor they consist on this study, it will be the lead or lead pot or leaf one pot. So that one you have a level. So in this situation, for example, you have more than three factor. Okay, you have maybe for the first preliminary study, so you have a 20 factor. Okay, so from the 20, maybe you want to reduce to 5 factor. Okay, or to 3 factor. Okay, so that one is we use DOE into our study. Okay. Okay, so that one is the phases of a design. Okay, in design of experiment for normally carry of the 4 phases. So the first one is a planning. Okay, during the planning it will be the always the same. Let's say you go for the PDCA, plan, do, check, and action. So you need to define the project. You need to have your objective. Okay, you need to plan your experiment and so on. After you do the planning, maybe you go for the next phases, as we call it, the screening, or you run, or you do the process characterization. Okay, in which you can conduct the initial research to identify the key variables that influence your quality side. So for example, in these phases, you have a 20. Okay, you have a 20 factor. Okay, from here, from this screening, you identify 5 of them, and then you follow up with just the next phases is optimization. So you want to determine from the 3 of them, which one, and then from the 2 level for each parameter, so which one, and then of course the last session, it will be the verification, or you will need to do the follow-up experiment to assess the predicted optimal condition to confirm the optimization result. Actually, all this planning, all these pieces is available in Minitab. So I will show how to get this information. So I open the Minitab. Okay. So how to get that information? You just go for the assistant. Okay, you go to assistant, you will see DOE. Okay, so you will see DOE, you see the plan and the create. So you just go for the plan and create. Okay, so you will see the plan experimentation process. Okay, So you click on this one, so you will see they will give you the information. So before you create a design, they will have the sequential, what it's mean by the sequential experiment itself. You can define, okay, your problem. After you define your problem, you will see the response, define your response, and then your goals. After that, you need to establish something like your budgeting, your timing, okay? And of course, you need to have some communicate with your stakeholder, okay? So Minitech give it you this planning side. And of course, they will see the objective. So what mean the objective? So just now I mentioned, let's say you have a 20. So for the assistant, it will be have a limited, you just only up to 15. But if let's say you have 20, you can use but not use the assistant. You will use the step menu. I will show after this. Okay. And of course, they will have the planning, screening, the experiment. Okay, so you need to plan your experiment first, identify the factor, define the factor level, and then define the appropriate sample size. Of course, you will need to have approval on this one. So all this information are available in the assistant. Or maybe you want to see more, okay, more comprehensive. You go for the hub, So you just type it into the hub browser, okay. So as long as you have a connectivity, your Internet Explorer in your desktop, so you can go for the hub and hub. So you just type it by the places. Maybe they will give you more information on that. Okay, for example here. Okay. Okay. So they will give it you the situation, something like one. Okay. You will see the planning phases. What is the planning? Okay, so they find all this one, the screening phases, the optimization, the verification phases. So all this one is available in Minitab. Okay, so of course, after you identify your factor, okay, your level, and then we need to identify the experimental design. So that one is the example or available design in Minitab. So we will see the screening design. So normally screening design, we use to see the most important factor in our process. After we identify that one, maybe we go for the factorial design. During do the factorial design, why we important and why all of more researchers use the factorial design, since in the factorial design they will study about the effect itself, and then they study about the interaction itself. Okay, and then of course we have something like advanced. After you identify in your process has something curvature or something like quadratic, linear, not the straight line, something like quadratic, cubical, or something like one. So you need to go for the response surface design. Or maybe your that one is a spatial design, is we call it the mixture design. And then of course we also have the Taguchi. So Taguchi actually we want to design, there will something like try to identify the controllable factor that minimize the effect of the noise factor. So all this experiment design, it will depend on your factor itself, the number of factor, the number of flavor, and then of course it will be regarding your costing and then your timely. Okay, so that one, they will be, if let's say you ask me which one is the best, it will depend on your number of factor. It will depend number of your level. Of course, it will depend on your costing. Okay, some want to reduce number of experiment. Maybe you will choose the Taguchi rather than factorial design. But in the factorial design, we have fractional and so on. Okay, so we have some guideline how to use the factorial design and screening and so on. Okay. So we try with this assistant. Okay, assistant, it will be easy for you to use the design of experiment in your cases. Okay, so for this case, they will use the food manufacturing company produce a cake for different customer group worldwide. So they have a 6 possible relevant variables, okay, impact into the yield. Okay, so mean to say that yield now is your response or your Y. And then they will have the factor of variables or parameter is a mixing time, the baking time, the temperature, the running time, the pressure, and then the supplier. So from the 6 list of this variable, they want to find the most important influence into the yield. So they have something like 6 factor with the 2 level. So if let's say you need to know how many, so 2 power of 6. Okay, 2 power of 6. So that one is 1 replicate. So imagine if let's say you want to see the 2 replication. Okay, so it's about 80 something. Okay, they run, you need to do the experiment. So that's why they come out with this different type of the design of experiment. Okay, it will be the best for you, it will be the best for others researcher, it will be the best for your situation. So say, can will be the simple way say that will depends on your factor level or your study. Okay, so how to get it this one? So we try open the mini tab. Okay, so we try with this one. So you go for the mini tab, open mini tab, and then of course you go for the go to the assistant, TOE. So since that one is a plan, so I do the planning. So I choose the plan screening experiment. Okay, so you see the all this one, and then of course you want to create the design first before we do the we identify the most important factor. So go for the create design. So you will see for this case our response it will be the yield. Okay. So the number of the factor, it will be the 6 factor just now. That one is the mixing time. Okay. That one it will be the mixing time. Okay. So there will be have a 2 level. Okay. There will be 2 level. It will be 100. The lower level 150. And then there will be the next is baking time. Okay. Baking time. So there will be 5, there will be 8 minutes. Okay, here it will be temperature. Okay, the same. There will be continuous data set 160, 180. So the next it will be the running time. Okay, so the same. Here to put the time. Okay, here it will be the 3 minutes 6, and then here it will be the pressure. Okay, so the same, there will be 10, there will be the 50, and here it will be the supplier. Okay, so supplier, it will be the categorical data set. Since they will be A, they will be B. Okay, so the number of the run, it will be 12, and then you click OK. So we will get the standard order design itself. So in the create the standard order, there will be the run order. Okay, here is the type, this is a block. If let's say you have the blocking, so blocking means that you do the different time of the experiment. Okay, and then there will be the mixing time, the baking, the temperature, the time, the pressure, the supplier, and after that, your response. So for example, you will have you do the experiment, the first run here, the mixer time is 100, the baking is 5, temperature is 160, the time is 3, the pressure is 10. So what the supplier A, so the yield of your response, it will be the maybe 62.6 and so on. So you need to run all these experiment for 12 run. That one is only one replicate. Okay, so for example, you want to do 2 replication, so it will be okay, but for the screening design, always we do only one replicate. Okay, so because we want to find out which one is the most important into the yield, okay, from the 6 factor here. After you do the experiment, okay, for example, I already have the experiment value here, okay, so you will go for the fit the screening model. Okay, just go for this output in the side, fit the screening model. Okay, so now Minitab will give you this information. Okay, so for this case, okay, they provide the percentage of variation. They look on the R squared here. R squared is quite good. It's a more than 70%. And then of course, they provide you the mean plot of the yield. So mean to say that the gray here is not significant. It will be here, it appear here, it will be significant. Okay, so they give you the diagnostics report, and of course they give it you the report card. Okay, so for this case, they will give it you some simple way. Okay, you just create your design. Okay, you create design. Okay, you create this one. You need to create this one. After you create, you run the experiment. You will get the value of experiment. After that, you fit. Okay, you fit the models, and after that, you will get the create the model. So from this study, you will see that the 3 of this significant into the yield. Okay, so they will give it you. Okay, so they give this information. So going to say that the first screen design, just only from the 6 factor, just only 3, it will be most important into the yield. Maybe from here, from the 3, you come out with the new paces to optimize them. Okay, so that one always we can say that maybe you will use the go to the stat, go to the DOE, go to the factorial design, or maybe you will use the response surface design. It will depend on your preference, or maybe you will check it on this, but is it have the something curvature or not curvature onto your study. Okay, so from here they will proceed with this one. Okay, so they will get all this information. Okay, you will get the most important here is the supplier, temperature, and then the running time. Okay, of course, after you know about these 3, so you proceed with the maybe go for the factorial design. So factorial design allow us to simultaneously study the effect of several factors on your process. So variety level of the factors rather than individually. So the factorial design itself, they will consist of this one. Okay. So that one, it will be 2-level full factorial, or you will use the fractional factorial, or you will use the split plot factorial, or you will use the Blackett-Berman, or you will use the general full factor design. So the design type here, it will depends on the number of the factor here. Okay, we see the number of the factor here. Okay, so for example, you have state the 2-level only, so you proceed with the 2-level full factorial. But if let's say you have a 3-level, so you can proceed with the general full factorial. Okay, so all this one is available in Minitab statistical software. Okay, so of course, factorial design, we use them because that one is the efficiently estimate the effect of each factor and the response. And then there will be estimate the effect of interaction, just now I mentioned, between 2 or more factor at the response. And then of course, in the factor design also, you can check it, the test of curvature in the response by including the center point in the design. Okay, so that one is the advantages of use the factorial design. So we have a lot of type of a factorial design here. Two-level factorial design, fractional factorial design, split plot, the bracket Bowman, your general full factorial design. Just I give it the information. If let's say your factor have a 3 level, so you can proceed with the general full factorial design. Okay. Of course, that one is the 5 reasons why we use the factorial design. The first thing is the most cost efficient. Okay, for example, you have a 2 factor with a 2 level, mean that 2 power of 2 equal to 4 run. If let's say you have a 2 level with the 5 factor, so 2 power of 5, it will be 32. Okay, so it will be sorry, it will 60. It will be the number of the experiment, how many experiment you will see. And then of course there will be estimate the interaction between. Okay, for example, you want to see the temperature versus the time. Okay, so you will see the interaction between them. Temperature versus the humidity. So you will see the interaction. And of course there will be orthogonal. Let's say it's the same. And then, of course, there will be comprehensive approaching to problem solving. And the 2-level factorial provide an excellent foundation for a variety of follow-up the experiment. Okay, so factorial design, it will be can be a 2 situation, whether you want to do the optimization or maybe after this you want to do some verification follow-up for the experiment itself. Okay. So here I will have one case study here. Okay, so one manufacturer of pack the cake mixes must determine the recommended baking time and temperature to the print on the box. Meaning to say that they will have a two factor baking time and temperature. But for this experiment, the first science replicate a full factor design precisely. So mean to say that 2 power of 2 with the 2 replication. So they will use the 8 run. Okay, 2 power of 2, 4. Another application 4, for 4 plus 4 is a 8 run. So they bake all the cake in a single oven in a single day. So no blocking variables is required. So the cake of the 30 minutes and 50 minutes. And then the temperature, it will be 3 to 5 Fahrenheit and 275 Fahrenheit. So the dancers calculate the moist content by the measuring the mass of the material before and after baking. So that one, it will be the how they get it, the response. Okay, the moist of the cake itself. They get it from the before and after experiment. Okay, so for this case, they will need 2 power of 2. Okay, with the 2 replication. So it will come in. What is the differences replication and repetition? Okay, replication means that is you need to run 1 up to run 4. After that, you need to repeat run 1 up to run 4. But for repetition, basically we use like, okay, run 1 first. Another second one is the run 1. The third repetition, and then so on. So it will be the variability. Okay, but for the replication, you need to see whole experiment, and after that you replicate another whole experiment. Okay, so that way it will be different between the repetition and replication. Okay. So for this case, we try create the factorial design using the Minitab. Okay, so no need go to and then manually. You will see on the Minitab. As long as you have the Minitab, so you will use the Minitab. Okay, so for this case, you go back to the Minitab. You go for the step. Okay, you will go for DOE. And then of course we try with the factorial design. So you will see in Minitab actually they provide you the sequence. Okay, the first you need to create the factorial design. After you create, maybe you analyze your factorial design. After you analyze, maybe you want to see the prediction. Okay, or you want to see the optimization. Okay, so you will see the create, you go for the create factorial design. But if let's say you do the manually, okay, no worries, the way you need to define on the custom factorial design. So you already have this kind of the run, or okay, the first run, it will be the temperature, this value, time, this value. The next, it will be this value. The next, it will be this value. So you already have to the manually. So no worries, you go back to the stack, go to call DOE, factorial design, you need to define custom factorial instead of the create factorial design. But for this round, I will use the create factorial design. See, just now I mentioned, give you two-level factorial, split, bracket, movement, and then general for factorial. So for this case, we have a 2, temperature, and then we have the time. So number of factor is a 2. So you will see display available design. Okay, so for this case, they will have the full here. Okay, full resolution 3, resolution 4. Okay, and so on. So they will have a two, the green color, the red color, and the yellow color. The green color is with the full factor. For example, is you have a 2 factor. So how many run you need to? 4 run. For example, you have a 3 factor here. So you need to full factorial design, mean to say you need to 8 run for the full. But if let's say you want to use the resolution 3, okay, so you just only run for the 4 run only. Okay, so you will see on this. So factor 4, how many run to full? It will be the 60 run. And so on. So you will see on this case. Okay, for this case, you will try with the full. Click OK, and of course, design here. So they will ask you for the full factorial design. So how many replicate? It will be 2 replication. So you will see that in the Minitab, actually, they never see, you cannot see the repetition. Okay, so it will be a replication only. Click OK, and of course, you have need to type your variable's name. Okay, for example, yeah, I will choose the temperature. It will be the lower here, 3 to 5. Here is the height will be the 37.5. And for the here is the time. It will be the 30. It will be here is the 50. Okay, and then you click OK, you click. Maybe you go for the option, you want to see the randomization. It will be most important into the study for the design experiment. And then click OK, and then you will see the result. So what mean the result? And then you click, just click OK. Now you will see this order. Okay. I think that one is you can do manually. Okay, you can do manually. But if let's say you have you imagine you have 5 factor, 5 factor with 2 level. So 2 power of 5, 32. So you need to have a 32 combination. Okay. So actually this idea of this one is coming from our maths during the I think maybe secondary school. It's a permutation, 2 power of 2. That one is the way is this combination, how to get this combination. Okay, so you will get this after you have this order. Okay, for example, run order 1, this temperature 3 to 5, your time is 15, and then of course your response here. So we see the response. So you measure your response the first run. The second run, it will be this value to this value, we'll get this value. So you complete all this 8 run of your experiment. Okay, so imagine now you already have this experiment, your response, you already have the response. After that, you will go back to the stack, go back to DOE. Okay, go back to DOE. go back to the analyze factorial design. Go back to the analyze factorial design. So you will see our MOS, it will be the response. Okay, go to the terms. Okay, for example, here you want to see the interaction. So you will up to this. Click OK. After that, you will need to go for the graph. Okay, you go 4 in 1. And then, of course, you click OK. Now you will get the factorial or normal for this case. So for this case, you will see the model summary. You look on the R square, it will be the higher R square. Okay, and then of course they provide you the p-value for each one, and here they provide you the equation of these models, and of course they provide you the Pareto chart. Okay, and of course they provide you the residual plot, saying that one if the statistical method, so you need to fulfill this assumption. Okay, after you this one, maybe you want to see something like you need go to stat TOE, go factorial design. You will see we have for the binary response. For example, you have your accept reject something that one. Okay, so you will use the binary response. But if let's say you have variability, not only one moisture, maybe you have moisture 2, 3, and so on. So you will go for the analyze variability. Of course, after this one, you will see the significant here. Okay, so that one if the will be the okay, the temperature, it will be the most important. Time also will be the most important into this study, and then interaction between them also the most important into the study. Mean to say that all this is important into the moisture. Okay, but back to this one, the temperature, what value it will be most to the is it is a 3 to 5 or 3 to 7, 5? Okay, so you need to drill down for this case. You how to get it? Go to stat TOE, factorial design. Maybe you go for the factorial plot. Okay, so for this case, you want to see all this, and then you click OK. Maybe you go for the option or the graph itself. Okay, and then you click OK. So you will see this study. So based on this main plot, you will see the height value of the measure is coming when your temperature is within 3 to 5. Okay, for the time, okay, the highest value of the moisture, it will be the 30 minutes. Okay, so if like you look on the less number of the moisture, so the 375, it will be the best level for the temperature. But for this one, it will be the less level for the time. So it will depends on your objective, whether you want to optimize it as a minimize, or you want to optimize it as a maximize, or you want to optimize it will be the targeting number. Okay, so we will see on this. So after you know, okay, temperature will be 3 to 5, the time will be the 30 minutes, or maybe you will see the interaction between them. So you will go next, maybe you go for the stat, go for the, TOE, you will see the predict. Okay, so you want to do the prediction. So now just only use the temperature 3 to 5, 375. Maybe you want to see the temperature 350. Okay, and then maybe for the time, now you use the 30 minutes and 15 minutes. Maybe you want to use the when your time is 40. But what is the moisture? This one, without do the experiment based on this one. So you go to the stat, go to DOE, factorial design, you do the predict. You do the predict. Okay, for example here, your temperature now you want to see 350. Your time you want to see about the 40. Okay, so you want to see the individual. Then you click OK. So we see on this setting. So you will get the new moisture. It will be 32.866. Okay, I will do, go to stat, go to DOE, go to factorial design. You choose the predict. Okay, you choose the predict. You choose the predict, and then you put your temperature or the time, and then you click OK. So you will see on this prediction. Of course, not to this objective. You want to go more than, you go for the OE, go for the factorial. Maybe you want to see the response optimizer. Okay, so that one it will be, so just now I mentioned, do not optimize it. Okay, but your goal is want to minimize it, the moisture. Okay, and then maybe you have a target, you can set up the target or so on for this one. Okay, I just proceed with the default, by the default only, and then you click OK. So they will give you this information. So by the targeting, by the lower, okay, based on this value, this is setting. Okay, so the most that one, it will be this one. Okay, the most thing, and then of course they provide you this one, so you can play around with this value. Okay, so you just draw down on this. Okay, you see on this, so you want to see lower number of the temperature here. Okay, or maybe you want to see the number of the time, okay, when this one, this value happen to your moist. So you will see on this on this study. Okay, so you will see on this. So of course, I will go back to the stat, go back to the UE, go back to the factor design. First, you create. After you create, you get the response value, you analyze them, you need to, you know about the optimization of the which one is the most important. After know about which one is more important, what level it will be, and after you know about the level, maybe you will use that to do the prediction. And of course, you want to optimize for your response. So all this one is available on this sequence. Or maybe you will use all the assistant part also for this. So you go for the assistant, DOE. Okay, so plan and create. Okay, so maybe you go for the create model, modeling design, or you want to conduct optimization, the experiment. So for this case, you create the model. Okay, the response here, what you would your response, the number of a factor. So how many factor you want, you get, and then you will see on the experiment. So the way, the objective will be the same, just only different menu. So instead you go for the stat, go for DOE, go the screen, factorial, okay, and then here, or you will see, or you could go for the assistant, go for DOE, go for the plan and create, and after that you can analyze and interpret them. Okay, so they will give you the step on this one. Okay, so we go back to this. So already done it for this Pareto chart. Okay, so in this Pareto chart, actually you will see the value here. Okay, it's above for this one, it will be significant. Okay, or maybe you will see on this P value. Of course, they do the prediction based on this value. Okay, based on this value. And we need to see the assumption. So for this study, all these are fulfill the assumption. The first one is a normally distribute. The residual, they will be must normally distribute, the constant of the variance, and then the random over at the time. Okay, so we do the factorial plot. Okay, we'll do the factorial plot. We have the this one. Okay, the lower, okay, and then the highest value of each factor. And of course, they will use the cube plot. Then you're not sure with this one. So I go back to this, okay, to cube plot to see the cube plot. Okay, I go back to the mini tab. Okay, I go back to the stat. Okay, go back to the stat, go back to the OE, go back to the factorial design, cube plot, or you will see the quarter plot. So for the cube plot here is the fitted. Okay, fitted means that it's the last model from your analyze just now. And then you click OK, so you will see the cube plot. for the fitted, mean for the moisture. But meaning that we capture the last part of this one, the last value from here. Okay, but if let's say you refit the model, so meaning that we capture the last part of the equation. Okay, so this one is the response optimizer. So I think a lot of researcher, a lot of the expertise do the design of experiment because they want look on this response optimizer. Okay, so that one it will be depends on your preference whether is you need to set your objective, minimize, maximize, or you have your own target. So to get this value, okay, so to get the value of this, and then maybe you will see the fit value when you get the best parameter. So for this case, this value, the fit value, it will be the best from the temperature 375, and then the time it will be 33 minutes. Okay, so there will be, I think it's a targeting. It will be the goal here is a targeting. So they will get this 25% of the moist when the temperature is this value, and at the time it will be this value. So you can play around with this one. You imagine this one is only two variables, okay? Two factor. But if let's say you have a 5 or you have a 3, so it more exciting to get know about this one. Okay, more factor, more clever, it will be more interest for you to do this response optimizer. Okay, so do you have any question about this topic? Okay, so we have one topic. Go to check. Okay, so basically we have a question here. Basically for the interaction during the screening part, it would depends, but most of the objective for the screening you want to find for the main factor or main parameter first, okay, without the interaction, because you want to get the more interesting most important study for your one. Okay, so we have another question here. Okay, if let's say I know of time, I will see. So if you have question, okay, when you look the p-value, okay, basically p-value is a less than 0.05. There will be the most guideline for all the statistical analysis. Okay, so include this DOE. DOE actually they will use the regression side. Okay, so I'll go back to the mini tab. Easy for you to see it. Back to this information. Okay, so I go to this one. So we see the p-value here. Okay, so p-value here. But this p-value is not, let's say, okay, 0.00 and 0.015. This temperature is most important. No, it just only it's important or not important. They not come out with the height important based on the p-value. Okay, no, you cannot bet that one. Just only the guideline, significant or not significant. To see more or not, so you need to go back to the factorial design. So that one is the mean of your uh, based on this experiment. Okay. Okay, so for the desire, you go to stat, go to the DOE, factorial design, your response optimizer, your setup here. Okay, and then maybe you go for the option. So you do here. So you want to set up your constraint, okay, hold on at the one, okay, constraint to the region. So you need to set up on this one to desire outcome. Okay, also this one. So go back to the response optimizer, you go for the option. So you will see on this desire. Okay. Have any other question? Okay, we have a lot of questions. I think for this, okay, in the Minitab statistical software, they provide you the analysis of this because that one is the, because this one is the response, okay, it's a regression. It will be same. You do is will give you the this one, the p-value here, okay, the p-value here. Say for this, they give it to. But if let's say your response, it will be some attribute, okay, so they will different measurement only, okay, they will deviance, okay, they not use the straight line, they will use the logistic regression, so it will be different on this case, okay. But for this case study, it will be our response is a y, okay, y, it will be the continuous, so that one they follow with this regression side. Okay, if let's say no, you can go back to the regression. So you will see we have the binary logistic regression, or maybe your response, it will be some ordinal, meaning that is a one is the low, two is the medium, okay, three it will be the higher. So you have the ordinary, okay, so you will proceed with the ordinal logistic regression. So the response, it will depends on your preference or on your study. Okay, so you can convert it from the attribute to continuous, something like one, or continuous to attribute to get this one. Because in this study, you want to see on this part to do the prediction, on this part, what of the most important predictor on this part. Okay. So I think the rest I will answer by the email. Okay. For those want to this material, so you can drop your email to the chat box. Okay, I will email after this. So in summary, design of experiment are powerful tools. You can see the successful study in our case study. You go for the www.minitab.com, go for the case study. So you will see a lot of case study, success case study from the Minitab itself. And then, of course, with the assistant, I think DOA will be more easier. Okay. And then, of course, this in 1 hour, that just only maybe it will give you some idea. After your process is a good, capable, okay, you identify the potential, so you do the experiment. So how to do the experiment? Using the design experiment. But what type of the design? It will depends on the number of your factor, depend on number of your labor, depend on your costing, depend on your budgeting, depends on your time. Okay, so but you want to see more, you want to see the response, surface design, the mixture design, the Taguchi design. So of course you can see, or you can join our training site. Okay, so we have a Singapore, Malaysia. So if let's say you're interested into this one, you can scan barcode here, or maybe I put the link. Okay, put the link on the one to if let's say you interest on this one. So thank you for your time and attention. So please follow us through the media social, Minitab Malaysia and Singapore from Facebook and link. And then of course, if let's say you want to see review back to this webinar, so subscribe to our YouTube channel, Minitab Malaysia and Singapore. So thank you. So happy learning.